Hello everyone and welcome back to our Java mini course. Java is an object-oriented language, and in this lesson we're going to take a look at an introduction to object-oriented programming with Java. So let's go ahead and get started. In this lesson we'll delve into object-oriented programming, or OOP, in Java. We'll cover key concepts like encapsulation, inheritance, polymorphism, and abstraction, and understanding their importance in creating modular and maintainable code. Some key OOP concepts are encapsulation, inheritance, polymorphism, and abstraction. Each concept plays a crucial role in structuring and managing code efficiently. Encapsulation bundles data and methods into a single class, restricting direct access to some components, enhancing data security, integrity, and modularity of your code. As an example of encapsulation in Java, the employee class in Java uses encapsulation by keeping name, age, and salary private. Public getter and setter methods allow secure access and modification, ensuring data integrity and security. On this slide is the example of our employee class, and it has the private attributes that we described along with the public getter and setter methods for these attributes, allowing secure access to the internal attributes. And although this is a simple example, one of the benefits of encapsulation is being able to hide the details of the implementation, making the code much more modular and maintainable. The next definition we'll look at is inheritance. Inheritance allows a subclass to inherit properties and behaviors from a superclass, promoting code reusability and creating a hierarchical class structure. So here's an example of inheritance in Java. The animal class is a superclass with common behaviors like eating and sleeping. The dog class inherits these behaviors and adds barking. The super keyword calls the superclass constructor. So here's an example that illustrates the concept of inheritance in Java. We have the animal class, and then we have the dog subclass that inherits from animal and extends it and adds the bark method. The next definition we'll look at is polymorphism. Polymorphism allows different class objects to be treated as a common superclass. In Java, it's commonly used in method overriding, where subclasses provide specific implementations of superclass methods. Polymorphism in Java allows the draw method to be overridden in a subclass like circle and rectangle. The correct draw method is invoked at runtime based on the object's actual type. So here's our example code for polymorphism. We have a class called shape, and then we have two other additional classes or subclasses of circle and rectangle, each with their own implementation of the draw method. And they're both invoked then from the main method that instantiates and calls these class. So that's our example of polymorphism in Java. Our next example is we'll take a look at abstraction in Java. In Java, abstraction is demonstrated by the vehicle class, which is an abstract and includes an abstract method engine start. The car class extends vehicle and implements start engine. This allows behavior to be defined in a vehicle while specific details are managed by subclasses. Abstraction in Java involves hiding complex details and showing only essential features. This is done with abstract classes and interfaces. So our code example here will show the abstract class vehicle and then the implementation of car, which is overriding the start engine method. So that's our example of abstraction in Java. In summary, object-oriented programming, or OOP, in Java involves key concepts like encapsulation, inheritance, polymorphism, and abstraction. Mastering these concepts helps writing effective, maintainable applications that can handle complex problems. Well, that's it for this lesson. Thank you so much, and I'll see you in the next lesson. Bye-bye.